Hello. Today we're going to talk about managing your weight. And I want to begin with a lovely quote that I found on Facebook because that's where all lovely things are found. Dieting is easy. It's like riding a bike. And the bike is on fire, and so is the ground, and everything is on fire because you're in hell. And if you've ever tried to lose weight, maybe you can relate to this. But first, the correct answer, folks, is C. But I wanted you to feel like you were in the classroom, so I had to throw in a poll question. Let's move on. We're going to talk about energy balance. And energy balance occurs when intake is equal to expenditure. In a few moments, I'll have a slide that tells you that when I use the word energy, I'm referring to calories. So energy balance occurs when the amount of calories that you are consuming is equal to the amount of calories that you are using or expending. And weight tends to be stable during this period. Positive energy balance occurs when the amount of calories you're taking in is greater than the amount of calories that your body is expending or using. During this period, body weight tends to increase, and you are said to be in positive energy balance. Negative energy balance occurs when the amount of calories or energy you're taking in is less than the amount of calories or energy you're expending. During this period of time, you tend to lose weight, and that is referred to as negative energy balance. Principles of energy balance are as follows. 1 pound of fat is equal to storing 3,500 calories. Now, I know that there's a lot of information out there saying a calorie isn't a calorie or that calories from protein is different from calories from fat. I will go over a study before this is over that kind of reinforces for me that a calorie is still a calorie. And for our purposes, this is what we're going to go with. In order to lose body fat, you need to be in a calorie deficit. You need to be in negative energy balance. In order to gain body weight or body fat, you need to be storing those calories, or a calorie excess needs to be created. So your body weight changes are based on the relationship of energy intake and energy expenditure. And this is quite the balancing act. Energy in, and for our purposes, we're going to talk about energy as equal to calories. Not the boost you feel after a strong cup of coffee, because that's from caffeine. But for our purposes, energy and calories are the same thing. So energy in are the calories that we're consuming. Energy out, or energy expended, is through 3 ways. BMR, or basal metabolic rate, physical activity and exercise, and something called the thermic effect of food. And we'll look at all of these right now. So energy intake is calories. The consumption of calories that we get from food and drinks. You need to know that all these calories add up, which is why I'm not a fan of sugar-laden sodas or juices, because I don't think folks should be drinking their calories unless you can afford it in what I like to call your calorie salary. These calories have been determined through something called a bomb calorimeter. What we're looking at is a piece of machinery that's known as this bomb calorimeter. You have your food in the middle in a little container, and it's surrounded by metal, and that's surrounded by water. And what happens is the water is heated up until that food item is totally broken down to ash. And that change in temperature is what's called a calorie. So calorie is actually a unit of heat. It's a measurement of heat. So energy intake are the calories that you consume. Energy expenditure are through basal metabolism, physical activity, and the thermic effect of food. Metabolic rate refers to how fast we burn calories in order to maintain normal body functions. And your basal metabolic rate is the minimum amount of energy required to maintain body functions apart from digestion. And this is the involuntary activities like breathing, nerve impulse transmission. Again, you don't want to have to think. Breathe in, breathe out. Those are involuntary activities. It's the energy required for the body to minimally function. Your heart to beat, your lungs to breathe, those involuntary activities required for living. It's usually determined during a fasting state when the body is completely at rest. It's not determined during sleep because some people move around a lot when they're sleeping. So it's determined when the body is at rest. And most of the energy expenditure in a sedentary person is used for basal metabolic activities. About 2/3 of the calories we consumed are used to maintain metabolic activities. There are a number of different factors that can affect your basal metabolic rate. Age, as we get older, our metabolism tends to slow down. Gender, males tend to have a higher basal metabolic rate than females because they tend to have a higher muscle mass. Testosterone tends to produce more muscle, and muscle is a more metabolically active tissue. This is why we recommend exercise, because for some people, and I'll talk more about this, it can help change their body composition. It will help decrease body fat and increase muscle mass. The reality is that change, that amount of calories required to maintain muscle, is not that much greater, but it certainly has a lot of other benefits besides increasing your basal metabolic rate. And I don't want you to exercise in order to be able to eat more calories. I think we need to separate exercise from eating, that we need to do that for two different reasons, and that's something that we hopefully can talk about. Physiologic state, people in a period of growth. When you're growing, you tend to have a higher basal metabolic rate. Pregnant women tend to have a higher basal metabolic rate. So there are different things that are going on in the body physiologically that can increase your metabolism. And surface area. A higher surface area or a greater surface area tends to use more calories. If we look at these boxes on the right, there are two different boxes. Well, actually, they both are made up of 8 boxes, but one is stacked, one on top of the other, and the other is in a 4x4. Is that right? 4x4? 2x2? 4x4. In any event, the one on the right has a greater surface area exposed to the environment than the one on the left. Imagine we're looking at two people. They weigh the same, but one is taller. The person who is taller has a greater surface area exposed to an environment and the body needs to be using more energy in order to maintain normal body temperature. A smaller surface area does not need to use as much energy. So that's why being taller is related to increased basal metabolic rate. The second way in which we expend energy is through physical activity, and this is voluntary movement. So BMR, or basal metabolic activities, are involuntary. Physical activities are voluntary movement of muscle. And it's the total amount of energy expended increases with body weight and intensity of exercise. So a larger person will expend more energy for the same physical activity as a lower weight person because they are moving more mass. And as they tend to lose body weight, the amount of energy expended for exercise can decrease. This is why it can be very frustrating to maintain the same rate of weight loss over time. The third category of energy expenditure is what's called the thermic effect of food. It's what's sometimes referred to as the food processing charge. About 5 to 10% of the total calories consumed is required for digestion, absorption, and assimilation of nutrients in the body. This is where that celery question sometimes comes up. Is it true that it takes more calories to eat celery than is actually in celery? And the absolute answer is no. 5 to 10% of the calories found in celery are used to digest, absorb, and metabolize celery. But the question that people should be asking is, why in the world would you be eating that much celery? We have different ways of assessing weight. One of them is body mass index. This is referred to as a broad stroke measure because it doesn't really tell us anything about the person's muscle mass or body mass. It's based on height and weight. It doesn't take into account age. It doesn't take into account gender or lean body mass. Now, I will tell you that I'm not going over numbers in this presentation because if you want to find out what your BMI is supposed to be based on your height and weight, you know where to look for those things. I don't want to cover them. So that's not going to be included in this presentation. Body composition is another way of assessing one's health. Let's look at these two people. They are the same weight, or at least they're supposed to be, depending on how well I formatted this picture. While their BMI would be the same because they're the same height and the same weight, their body composition is different. The person on the right has a higher muscle mass than the person on the left. So body composition is a better indicator in a number of cases of somebody's health risk. And then there are these other ways of assessing body composition. Some of you may have used skin calipers, the one in the lower right. The more experienced the person is at using these calipers, the more accurate the measurements will be. Electrical impedance is when an electrical current is sent through the body. Electricity travels differently through different tissues, and that can give you an estimate of body fat. Nobody's ever been electrocuted, so this is a very low-level electricity. Underwater weighing, because different tissue displaces water at a different rate. The bod pod is something that can be used to assess body composition. So these are a number of different tools that can be used to look at body composition. And then there's something called waist circumference or waist to hip ratio. This uses the high-tech instrument known as the tape measure. And actually, in older adults, it can be a better predictor of health risk than in younger adults. And this is where we get the apple versus pear person. The greater the amount of body fat around the abdomen, we would call that person an apple-shaped. The greater the amount of fat around the hips would be a pear-shaped person. And that fat found in the middle of the, the amount of fat found in the abdominal area, the apple-shaped person, we refer to that as intra-abdominal or visceral fat, fat found within the abdomen. Viscera is organs, so the amount of fat found in and around the organs. This person on the right has a greater amount of intra-abdominal or visceral fat, and this is associated with higher risk of chronic illnesses like type 2 diabetes, high blood pressure, and high blood cholesterol or heart attack risk. There are a number of different factors involved in gaining weight or becoming overweight. Metabolic factors include something called the set point theory. And I have here in parentheses thermostat analogy because it's to remind me to talk about how this set point theory refers to the hypothesis that your brain regulates your weight, that in your what's called the ventromedial hypothalamus, no, you don't need to remember that, but you have a predetermined amount of weight. And if you go above that weight, your body tends to increase energy expenditure and decrease appetite. And if your body goes below that weight, for some reason your appetite increases and you wind up burning less calories. That's the thermostat analogy. Keep in mind that if you set the thermostat at a certain temperature, when it goes above that temperature, the air conditioning would go on. If it goes below that temperature, the heat would come on. So if you're using that as an analogy for set point theory, if your weight goes above that predetermined weight, your body works to lower that weight. If your body goes below that predetermined weight, your body works to increase back to that weight. You need physical activity. So what this is saying here is that maybe the set point theory doesn't hold for everybody. Remember, it's a theory. I'm not really sure how they can check this in anything other than mice. And we know about mouse research. Muscle tissue has a higher metabolic rate than fat. I mentioned this earlier, which is why we recommend people be active and increase their muscle mass. So yes, it does have a higher metabolic rate. It does burn more calories at rest. Not as much calories as people like to think, but as I said, there are a lot of benefits to improving your body composition beyond the fact that you may be burning more calories at rest. There are a number of hormones that can be involved in weight control. And these are the hormones that may be involved in that set point theory. Leptin is a hormone that's produced by fat cells that tends to lower or slow metabolism, while ghrelin tends to stimulate appetite. It tends to be released before meals and can be reduced by exercise. It's thought that if this set point theory was indeed a fact, if it could be proved to be correct in humans, that when you lose weight, when you go below your set point, that might increase the ghrelin. And when your weight goes above that predetermined set point, you might increase your leptin amount. Heredity can be involved in weight. These are pictures of the same young man who at the age of 3, on the left, you can see he was large, but by the age of 7, he had grown. What was found out was that this young man experienced a deficiency in the production of leptin. And leptin's that hormone that makes you feel full. And if you have a deficiency of leptin, then you won't experience fullness and you would continue to eat. Once this young man's leptin was replaced, he began to experience normal regulation of calories in versus calories out, and he took off that weight. When this was discovered, it was thought that perhaps leptin could help people lose weight, that giving people leptin would help lower their appetite and make them feel fuller sooner. However, what was discovered was that giving folks leptin only worked if you were leptin deficient. That didn't prevent snake oil salesmen from trying to sell you books and supplements based on this information. Obese people have billions more fat cells than people of average weight. And heredity can also affect the number of fat cells that you have, but dietary habits also contribute. Fat cells don't seem to go away when you're losing weight, and our fat cells are living, active cells that send out lots of signals, and the hypothalamus is an organ in the brain that I mentioned earlier that may be controlling weight. Women tend to have a higher percent of what's called essential fat than men. It's essential because it's used for pregnancy, for child rearing, for producing hormones to feed the newborn. And it may be one of the reasons why it's easier for men to keep off weight than it is for women. Women may be able to lose weight, but it may be harder for them to keep it off. And part of it may have to do with this essential fat. Let's look a little bit more closely at adipose tissue. And adipose is another name for fat. This is a picture on the left of adipose tissue that is made up of lots and lots of adipose cells. It stores excess energy as fat, and that energy can come from too much protein, too much carbohydrate, or too much fat. Any macronutrient consumed in excess of what the body needs will be stored as fat. Adipose tissue also sends out signals, and that can help regulate energy balance. So adipose tissue or adipose cells regulate energy balance through different hormone production, and these hormones can be that leptin and that ghrelin. Our adipocytes, adipocyte is another name for fat cell. And the number and the size of these fat cells can affect our ability to maintain a healthy weight. Hypertrophic growth refers to increase in cell size. Hyperplastic growth refers to increase in cell number. And how does that bear out when we're looking at weight control? This is a fat cell. It has a mitochondria, it has a nucleus, it has cytoplasm like all other cells, but it has this central core of triglyceride, and triglyceride is a type of fat. During weight gain, fat cells increase in size and or number. So in this first part of the slide, the example shows that during hypertrophic growth, when you are in positive energy balance, the cell is increasing in size, experiencing hypertrophic growth. But what can also happen is that the cells can increase in number. This is referred to as hyperplastic growth. So when intake continues to be greater than energy expenditure, not only do the fat cells increase in size, but they increase in number. The thing is that when you lose weight, when you begin to lose body fat, those cells decrease in size, but they don't necessarily decrease in number. And that hypothesis may explain why for some people it's harder to keep weight off. They have the same number of fat cells, the fat cells just don't contain the same amount of fat. And because those fat cells are always present, it may, and the operative word here is may, make it easier to put weight back on.